put sulfur and fluorine. How much sulfur do you have? 29.7% sulfur. Okay, Isabel, do you know how we got that number? 100% is total. Minus 70.3. 29.7. Okay, so assume a 100-gram sample. Therefore, we've got 70.3 grams of fluorine, 29.7 grams of sulfur. Divide each by its molar mass. What's the molar mass of fluorine?
19.
So what's 70.3 divided by 19? 3.7? No.
Wait.
You need at least 4 sig figs. Because there's 3 on the top, 4 on the bottom. So
4, right?
I don't know.
You said 4.
4 sig figs, so 0, 0. How about sulfur then? 29.7 divided by 32.07. Thank you. Okay. Do you understand what we got?
Yes.
Okay. What do we do with these numbers?
Divided by the smallest.
Divided by the smallest. Any number divided by itself is 1, so there's 1 sulfur. And this divided by the smallest number is 4. So therefore, the empirical formula, SF4. So we have the mass of aluminum, the mass of a bromine molecule. If we add them up, we get 186.78. The mass of aluminum bromide is 266.68. Now, if we were going to do an experiment, we had a little flask, and here we had some aluminum foil, and we added some bromine liquid. We could mass that, and that would be our initial mass. Then we shake it up, and we get aluminum bromide. Here we go. We've got an initial mass. We've got a final mass. The flasks were stoppered, so no material could go in or out of the flask. And the masses are equal. The mass before is equal to the mass after. We didn't lose any substance. We didn't add anything extra. Total mass before we started is equal to the total mass afterwards in an experiment. Did that happen in our calculation up at the top? Are these two numbers equal? No. Now, balance that chemical equation. Balance that equation at the top. Aluminum plus bromine makes aluminum bromide. What are the coefficients? 2, 3, and 2. Okay, now, if we take this molar mass and multiply it by 2, what do we get? You're taking the molar masses of our substances and we're multiplying them by the coefficients from the balanced chemical equation of conservation I can't spell. Conservation of mass. We know that matter is not created or destroyed during a chemical reaction. It's just rearranged. Law of conservation of mass. Matter is just rearranged during an experiment, not created or destroyed. So we have to balance chemical equations to follow the law of conservation of mass. Stoichiometry is the relationship between substances in a balanced chemical equation. Has to be balanced. And we represent them as ratios. We represent stoichiometric relationships in ratios. Produce 5 moles of aluminum bromide. How much aluminum did I start with? How much bromine did I start with? 5 moles of aluminum bromide. To figure out the moles of aluminum that you need the ratio of aluminum to aluminum bromide. You get that from the balanced chemical equation. So the coefficient for aluminum is 2, and it's also 2 for aluminum bromide. So 5 times 2 divided by 2 is 5. Aluminum bromides cancel, so we have 5 moles of aluminum needed. We're going to do the same thing for bromine. This time bromine's on top, aluminum bromide is on the bottom. What's the coefficient for bromine? 3. So 5 times 3 divided by 2, 7.5 moles of bromine. Use your mole ratio from your balanced chemical equation to do your conversion. Balanced chemical equation, so now how much ammonia will be produced from 3 moles of hydrogen? That has to be in the bottom of the ratio because you want it to cancel. H2. What has to be on the top because you want to find it? NH3. NH3. So, what's my mole ratio? Do you know where I get the 2 and the 3 from? If you don't, from the numbers in front of them in the balanced chemical equation. That's where I'm getting those numbers from. So now 2 times 2 is 4 divided by 3